Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. In this video, we discuss the solutions of the 4 questions from the section Matrices and Determinant. And this is the second part of the 5 parts of the video on matrices and determinants. Right. This is the question that has appeared in the JEE Main exam held on 29th January 2025 in the second shift. The given question is, let capital A is equal to Aij be a 2 by 2 matrix such that the entries Aij belong to the set consisting of 0, 1 for all I and j. Let the random variable capital X denote the possible values of the determinant of the matrix A. The random variable X denotes the possible values of the determinant of the matrix A. Then the variance of X is, we are given 4 options. Right. Let's now discuss the solution of the problem in detail. We have capital A is Aij, a 2 by 2 matrix, and that is the first row is A11, A12, second row A21, A22, where the entries Aij belong to the set consisting of 0 and 1. That means the entries are either 0 or 1. Let S be the set of all 2 by 2 matrices with the entries from the set consisting of 0 and 1. That means S is the sample space in this discussion. Now, n of S, how many elements, how many matrices are there in S? So, every matrix has, in the first row 2 elements, second row 2 elements, and each element can take the values either 0 or 1. So, this A11 can take 2 values, 2 into A12 takes 2 values, 2 into 2 into 2 into 2, that is 2 power 4, that is 16 matrices are there in the solution, in the sample space. Right. Now, let xi be determinant of A, that is the determinant, and this is A11, A22 minus A12, A21. And the determinant, because the elements are either 0 or 1, the determinant will be minus 1 or 0 or 1. And what is capital X? Capital X is the random variable which takes the values, and it denotes the possible values of the determinant A. Now, capital X is equal to xi. Xi is the determinant of A, and it is minus 1, 0 or 1. So, capital X can take the values minus 1, 0 or 1. We continue in the next slide. Right. So, what we are doing here is we are enumerating all matrices and then count how many elements are there with the determinant 0, with the determinant 1, with the determinant minus 1. So, here we have written all the matrices with the first row 0, 0. So, these are 4, and their determinants, now when I write in red, the determinant is 0. All the determinants is 0. Second row. So here first row is 0, 1. All of them, we have written 4 of them. And the blue ones will tell you the determinant is -1. And here the first row is 1, 0. And the black ones will tell you the determinant is 1. Lastly, first row is 1, 1. And this is the case. That is, with the determinant 0, 2 are there. With the determinant 1, 1 is there. Determinant -1, 1 matrix is there. Now, N0 be the number of matrices with the determinant 0. How many are there? Count the matrices which are in red. They are 10 in number. Now, the probability of the random variable x is equal to 0 is the number of matrices with the determinant 0, N0, by n of s. That is 10 by 16, that is 5 by 8. N1, the number of matrices with determinant 1. How many are there with determinant 1? 3 are there, 3. So the probability of x is equal to 1, capital X, the random variable capital X takes the value 1, is equal to N1 by n of s, that is 3 by 16. So also n suffix -1, number of matrices with determinant -1 is 3. Now the probability of x is equal to -1 is n -1 by n of s, that is 3 by 16. Right. Now we recall the formula for the variance of x. The variance of x is equal to the expectation of x square minus the square of the expectation of x, where the expectation of x is given by sigma xi multiplied by the probability of x is equal to xi. So xi is 0, 0, that is equal to 0 multiplied by probability of x is equal to 0, 1 into probability of x is equal to 1 plus -1 into the probability of x is equal to -1. So substitute the values of the probability of x is equal to 0, probability of x is equal to 1, probability of x is equal to -1. Substitute and simplify, we will get 0. We will get 0. Now E of x square. E of x square is sigma xi square multiplied by probability of x is equal to xi. So take the xi and square it. So it will be 0 square into probability of x is equal to 0 plus 1 square into probability of x is equal to 1 plus -1 square into probability of x is equal to -1. Substituting and simplifying, we will get 3 by 8. 3 by 8. We are ready, and we can calculate the variance of x. The variance of x is given by the expectation of x square minus the square of expectation of x. That is 3 by 8 plus 0. That is 3 by 8. Let's look at our options. Our answer 3 by 8 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of the given problem. Right. This is the question that has come in JEE Main exam held on 29 January 2025 in the second shift. The given question is, let alpha comma beta, alpha not equal to beta, be the values of m for which the equations, 3 equations are given in 3 unknowns, and first equation is equal to 1, the second equation is equal to m, the third equation is equal to m square. Call this as a system of linear equations. Call this equation as the 1. Equation 1. These equations have infinitely many solutions. Then the value of sigma n is equal to 1 to 10 in brackets n to the power of alpha plus n to the power of beta is equal to. So first of all, we take the system of equations 1, and find out those values of m for which this system has infinitely many solutions. We are given 4 options. Let's now discuss the solution of the problem. We first find the values of m for which the system of equations given in 1 have infinitely many zeros. The system 1 of the equations have infinitely many solutions if delta is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0, where these delta 1, delta 2, delta 3 stand in the usual standard way, where delta is the determinant of the coefficient matrix, that is the determinant of 1, 1, 1, 1, 2, 4, 1, 4, 10. Expand this determinant by first row, simplify, we'll get 0. So delta is equal to 0 is satisfied. Now delta 1 is equal to, the delta 1 is same as the determinant delta with the first column of delta replaced by 1 m square, 1 m square. And expanding the determinant by first row, we get this, and simplify, we'll get 2m square minus 6m plus 4 is equal to 0. Cancel 2 throughout, we'll get m square minus 3m plus 2. And the factorization is m minus 1 into m minus 2 is equal to 0. The values of m is 1, 2. So for these values of m, the given system of equations have infinitely many solutions. And it is given alpha and beta are the values of m. So let us take alpha is equal to 1, beta is equal to 2, and then answer the question. Right, we got m is equal to 1. Note now one question a student perhaps may ask is, sir, what happens for delta 2 is equal to 0? Delta 2 is equal to 0, delta 3 is equal to 0. So write down delta 2, don't say it is equal to 0, write down delta 2. In that, m is equal to 1 you substitute. Then the second column 1m square will become 1, 1, 1, which is identical with the first column. Therefore, two columns are identical, therefore the determinant is 0. Now m is equal to 2, substitute in the place of second column for m is equal to 2, 1, 2, 2 square. So that is equal to, you will get 1, 1, 2, 2. So m is equal to 2, 1, 2, 4, right? So you will now expand, then you will get 0. So for all these things, for m is equal to 1, 2, these things are also 0. Right. So that m is equal to 1, 2 are also satisfied in this case. Right. Given alpha and beta, alpha not equal to beta, are the values of m for which the system 1 have infinitely many solutions. Now the answer to the question. Let alpha is equal to 1 and beta is equal to 2. Then sigma n is equal to 1 to 10 in brackets n to the power of alpha plus n to the power of beta. That is sigma n plus n square. So that is sigma n plus sigma n square. Sigma n is the sum of the first 10 natural numbers, that is n into n plus 1 by 2. So n is 10 into 11 by 2. Plus the second one, sigma n is equal to 1 to 10 n square, the sum of the squares of the first 10 natural numbers, and it is given by n into n plus 1 into 2n plus 1 by 6. So n is equal to 10, you substitute. So it is 10 into 11 by 2 plus 10 into 11 into 2n plus 1, that is 21 by 6. Simplify, we'll get 440. Let's look at our options. And our answer 440 appears again as option 4. Therefore, the answer to this question is option 4. And that is the detailed discussion of the solution of this problem. Right. We move to the next question. This question has appeared in the JEE Main exam held on 29 January 2025 in the second shift. Let A is equal to Aij be a matrix of order 3 by 3 with Aij is equal to root 2 to the power of I plus j. If the sum of all the elements in the third row of A square is alpha plus beta times root 2, where alpha beta are integers, then alpha plus beta is equal to. We are given 4 options. Let's now discuss the solution of the problem in detail. We have Aij is a 3 by 3 matrix where Aij is equal to root 2 to the power of I plus j. Let us write down the matrix capital A, that is equal to root 2 to the power of I plus j, that is root 2 to the power of 1 plus 1, root 2 to the power of 1 plus 2, root 2 to the power of 1 plus 3. Likewise, fill up all those places. Then you will get the first row root 2 square, root 2 cube, root 2 to the power of 4, etc. In all these things, root 2 whole square is common. Take out. So root 2 whole square is equal to 1 root 2 2. Here root 2 square is taken out. Root 2 whole cube means root 2 2 2 root 2. Third row 2 2 root 2 4. So root 2 whole square is 2 into the matrix. Right. What is that we want? We take this matrix A and compute the third rows of A square. Right. We have the matrix capital A. Multiply. A square is 2 times the matrix plus into 2 times the matrix. 2 into 2, 4. 4 times. Will not compute all the entries. We compute only the entries that are in the third row and then sum it up. Right. So 3 1 element. Take the third row, multiply with the first column, and that will be 2 plus 4 plus 8. Right. Now take the third row, multiply with the second column, then you will get 3 2 element. So we get 2 root 2 plus 4 root 2 plus 8 root 2. Right. Multiply the third row with the third column. Then you will get 4 plus 8 plus 16. That's equal to 4 into first row, second row, leave, and the third row elements will be 14 plus root 2, 28. So what is that you want to write? We want to write the sum of all the elements in the third row of A square. So now sum of the elements of the third row is 4. 4 is outside, therefore you have to multiply every element inside. So 4 into 14 plus 14 root 2 plus 28. That is 4 times 14 plus 28, 42 plus 14 root 2. Multiply 42s are 168 plus 14s are 56 root 2. So this is given to be alpha plus beta root 2. Therefore alpha is equal to 168 and beta is equal to 56. What's that we want? We want alpha plus beta. So alpha plus beta is equal to 168 plus 56. That is equal to 224. So where is our answer? The answer 224 is appearing against option 2. Therefore the answer to this question is option 2. That is the detailed discussion of the solution of this problem. Right. This question has appeared in the JEE Main exam held on 29 January 2025 in the first shift. Let A is equal to Aij, given to be a 2 by 2 matrix, whose first row is log 128 to the base 5, log 5 to the base 4. Second row is log 8 to the base 5, log 25 to the base 4. If capital Aij is the cofactor of the entry Aij and Cij is equal to sigma k is equal to 1 to 2, Aik, Ajk, 1 less than or equal to I, comma j less than or equal to 2. That means I and j takes the values 1 and 2. And C is the matrix Cij. Then 8 times the determinant of C is equal to. We are given 4 options. Right. Now, we are given capital Aij is the cofactor of Aij. Agreed. Agreed. It is given Cij is sigma k is equal to 1 to 2, Aik, Ajk, 1 less than or equal to I less than or equal to j less than or equal to 2. You remember, right, let first of all C11 is equal to sigma k is equal to 1 to 2, I is 1, A1k multiplied by capital A1k. So, an element multiplied by its corresponding cofactor, and k, the column, is running on 1 to 2 in the case of a 2 by 2 matrix. Then it will be determinant of A. Then it is determinant of A. Right, you remember this, right. C12 is equal to sigma k is equal to 1 to 2, A1k, A2k. Now, this 1 not equal to 2, that means an element multiplied by the cofactor, not the corresponding cofactor, but by a different cofactor, then the product will be 0. C21 is also 0. C22, in this case, A2k multiplied by its corresponding cofactor A, capital A2k, k is equal to 1 to 2 is the determinant of A. Now write down capital C. Capital C is Cij, that is the 2 by 2 matrix C11, C12, C21, C22. That is C11 is C11 and C22 each is equal to determinant of A, the remaining 2 are 0. So, determinant of A 0, 0, determinant of A. And we want 8 times determinant of C. So, 8 times determinant of this one. Then now expand the determinant, 8 times determinant of A square. So, to get the answer, you require determinant of A. So, let us take the matrix A and calculate determinant of A. So, determinant of that is A, B, C, D is AD minus BC. So, multiply. So, multiply. Now, to simplify this one, we use the change of base formula. That is log 128 to the base 5 is written as log 128 to the base 10 by log 5 to the base 10 multiplied by, this is written as log 10 to the log 25 to the base 10 by log 4 to the base 10 minus log 8 to the base 10 by log 5 to the base 10, log 5 to the base 10 by log 4 to the base 10. Right. Log 10 to the base 128, that is 2 power 7, so 7 times log 2 to the base 10, right, and log 5 to the base 10 into, this is a log 25 to the base 10 is 2 log 10 to the base 5, that is 5 square, by log 4 is 2 log 4, 2 log 2 to the base 5. Like that we have written. Simplify. Here you will get log 5 and log 10, 2 cancels, 7 minus 3 by 2. that is 11 by 2. So come back here and substitute for determinant of A 11 by 2. So that is equal to 8 times 11 by 2 whole square, that is 121 by 4. Simplification will get you 242. So where is the answer? Option 1. So the answer to this question is option 1. That is the detailed discussion of the solution of the problems. In this video, we have discussed 4 problems based on the concepts and results of matrices and determinants. And all the problems looks to be easy ones. I am sure that you have understood the solutions of these 4 problems. Thank you for watching my video. Now, please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.